Hey there, Mr. Weaver here, and this is Geometry Lesson 7, Describing Transformations with Coordinates. After this lesson, you need to be able to use coordinate notation to describe translations, reflections, and rotations. Let's learn. Translations using coordinates. The coordinates of a translated image can be determined using coordinate notation. The value of A is the number of units the pre-image is translated left or right. The value of B is the number of units the pre-image is translated up or down. Here, since point J moved 6 units to the left and 2 units up, we can describe that translation using coordinate notation, which would look like this. All that's really saying is that we took the x coordinate and subtracted 6 from it. We moved it left 6. And we took the y coordinate and we moved it up 2. We added 2 to it. If we look at the coordinates here, 3 to -3, that went 3 minus 6 is -3. 2 to 4, 2 plus 2 is 4. So we can use this notation here to quickly describe what happened in our transformation. So our key concept here then is translations using our coordinates. For horizontal translations, we add a value to the pre-image's x-coordinate. And for vertical translations, we add a value to the pre-image's y-coordinate. So they use A for x and B for y. So here, if we're looking what happened to it, A to A prime went left 3, down 2. B to B prime went left 3, down 2. C to C prime went left 3, down 2. So we can see this, it went left, and I can see that because it's negative, left 3, and down 2. So left 3, down 2, down again because it's negative. If it goes to the right or goes up, then it will be plus instead. Example 1, translate using coordinates. Triangle XYZ has vertices x, -1, -2, y, 6, -3, and z, 2, -5. Write the coordinate notation for a translation of 2 units left and 1 unit up. Then write the coordinates of triangle x prime, y prime, z prime. So first, let's write the coordinate notation for 2 units left and 1 unit up. Because it's 2 units left, we're going to subtract 2 from each x coordinate. And to move it up, we're going to add 1 to each y coordinate. So here I can see -2 plus 1. So our coordinate notation would be this whole thing together. Our original coordinate goes to taking 2 away from the x coordinate and adding 1 to the y coordinate. Now that we have our coordinate notation, part B, we can use that coordinate notation for our translation for every coordinate that was on the triangle. So then we can use that on our vertices to create our image. So here we can see our original vertices of our pre-image. We're going to go left 2 each time and up 1. So left 2 from -1 would be a -3. Up 1 from -2 would be -1. Left 2 from 6 would now be 4. Up 1 from -3 would be -2. And then z to z prime would now be at 0, -4. So our new vertices for x prime, y prime, z prime would be -3, -1, 4, -2, and 0, -4. Check your understanding. First, write the coordinate notation based on what it says, and then what are the coordinates of the image. Pause the video now and complete the check. Check your answer. First, it says 6 units left and 9 units down, so we would do left as -6, down as -9. If we want to find the coordinates of our image, every x coordinate we're going to subtract 6 from, every y coordinate we will subtract 9 from. So 3 minus 6 is -3, 1 minus 6 is -5, -5 minus 6 is -11, and then for the y's subtracting 9, 2 minus 9 is -7, -3 minus 9 is -12, 0 minus 9 is -9. Let's learn. Reflect using coordinates. This shows triangle ABC and its image after a reflection across the x-axis. Write the coordinates of the image. So we can see it was flipped down across the x-axis. What are the coordinates of the new image? We have A is 1 over -2, B 2 over and -4, C 4 over and -1. With reflections, notice one of the coordinates stayed the same, and the other coordinate is the opposite of what it was. So depending on which way you flip, If you flip across the x-axis, then the x is going to stay the same and the y will become the opposite. If you were to have flipped across the y-axis, then the y would stay the same and the x would be the opposite. So here, our coordinate notation, we take our original coordinate and change it to, because we flipped across the x-axis, x stays the same, but y becomes the opposite. And that is very helpful for reflections because, again, you can figure out what the coordinates are real quick without actually having to draw it out. But this quick method will really only work if you are flipping across one of the axes. If it's across a different line, then you're going to end up having to do a reflection and technically a translation in order to come up with the correct coordinates. But for right now, across the axis will just be same as one, opposite of the other. So here we can see across the y-axis, notice this time, the x coordinates are the opposite, but the y's are the same. So across the y-axis, you will have the same y, but opposite of x. So our coordinate notation this time would be opposite of x, same y. Example 3, reflect using coordinates. Our triangle has these coordinates. The triangle is reflected across the x-axis. That's important to know because when we do it across the x-axis, the x-coordinate remains the same, which means the y-coordinate is the opposite. So our coordinate notation, same x, opposite of y. So if we do that, same x each time, opposite of y, same x, if it's 2, it's going to stay 2. 1 would become -1. Same x, opposite of y. Same x, opposite of y. 0 doesn't really have an opposite, so 0 would just stay 0. These are our coordinates of our now image. So again, this is a much quicker way than drawing out all of the shapes. Check your understanding. Read through and write the coordinate notation for a reflection across the y-axis, then write the coordinates of the image. Pause the video now and complete the check. Check your answer. First, your coordinate notation. Because you're flipping across the y-axis, x goes to the opposite, y stays the same. And then our coordinates would be same y each time, opposite of x. Let's learn rotations about the origin. The coordinates of an image rotated clockwise about the origin can be determined using coordinate notation. When a figure is rotated about the origin, the center of rotation is 0, 0. Each point of the original figure and its image are the same distance from the origin. A rotation's pre-image and image are congruent. In the previous lesson, we learned about rotations about a specific vertex. This time, though, we're going to do it around the origin. That way we can use coordinate notation. When it's around a vertex, coordinate notation is not quite so easy. So 90 degrees clockwise about the origin, or this could also be 270 degrees counterclockwise if you happen to need it. For our coordinate notation, the x-coordinate is the same as the y-coordinate in the original. The y-coordinate is the opposite of x, of the pre-image. So a quick way you can remember this is if you just switch them and then make the y-coordinate the opposite. So switch them, make the new y-coordinate, make it opposite of what it was. For 180 degrees, this is the easiest one to remember. They are both just the opposite of what they were. So if it was x originally, now it's the opposite. Y is now the opposite of y. So 180 degrees, when they tell you to do a 180 degree turn, they're telling you to go the other direction. Rotating it the same way, take the opposite of the x and opposite of y. And then 270, this is the same as a 90 degree counterclockwise. It's similar to 90 degrees clockwise. We switched the two numbers, but this time that first number changes its sign to the opposite. When in doubt, if you can remember that they switch places and one of them changes signs, if you graph it out and it's rotated the wrong direction, then you know you did the wrong one, so it must have been the other coordinate that switched signs. Example 2, rotate using coordinates. Our triangle has these vertices and it's rotated 90 degrees clockwise about the origin. What are the coordinates of our new image? So when we're rotating at 90 degrees about the origin, the x-coordinate is the same as the y-coordinate, and the y-coordinate is the opposite of the x-coordinate. They switched positions and we made the new y-coordinate the opposite. So our coordinate notation would be now y and -x. So what would this do to our coordinates? In my head, I'm going to switch these two around, and then I'm going to make the second one the opposite of what it was. So I know that 4 now goes over in first place. -4 would switch and make it the opposite, so now it's +4. For E, 2 would go over to the first place, -1 would go to the second coordinate, and make it the opposite, so now it's +1. So F prime would then be 1, +3. This would be the coordinates of my image. Check your understanding. Write the coordinate notation for a rotation of 180 degrees, and then what are the coordinates of the new image? Pause the video now and complete the check. Check your answer. First, because it's 180 degrees, our coordinate notation is just the opposite of x and the opposite of y. So, our coordinates then should just be the opposite of whatever numbers were there. M prime is at -2, -5, N prime -6, -4, P prime -6, -1, and Q prime is at -2, -1. Opposite numbers of what was there.